Okay, now let us start with all the training module, like what we will cover in the 40 hours training. We'll start from the very beginning, like what is IoT and introduction of IoT and their application, their architecture, and like then we will move on the how it is possible to convert a normal device into the IoT enabled device, or in the smart device, like by use of some hardware, some actuators, some sensors, some wireless technology, some IoT protocol. So first is all over it is the theory part, and we will cover this thing. Then after we will move on the practical things, like if we will use the Arduino as the hardware platform or the Raspberry Pi. Then first the architecture of the all the hardware platform like Arduino, what is the integral part of the all what is the component, all that things. Then we will interface the different type of the sensor with that hardware, either that is Arduino or the Raspberry Pi. We'll work on the both. And we will also start from the very basic programming language like embedded C and the Python for the Raspberry Pi, or embedded C for the Arduino Uno. How to programming, how to like embedded program it, how to upload the program, all that basic things. Then like after the interface of normal sensor, or like you can see here the temperature sensor DHT11 or DHT22, distance sensor, ultrasonic sensor, SCSR04, light sensor, LDR, moisture sensor, and gas like MQT, and different actuators like servo motor, relay, DC motor, that things. And we will also work on the different pins like analog pin, digital pins, PWM pins. PWM means pulse width modulation, that pins. And then, well, this is all like wireless technology, different wireless technology, Bluetooth, Zigbee, Z-Wave, NFC, and different IoT protocol like HTTP, MQTT, and COAP. So we will work with practical with all three IoT protocol. And first we will start with the TCP and UDP. TCP and UDP is like a uh, IoT protocol, transport layer of the protocol, which is responsible for send the message or the data from source to destination. So we will by the Python socket programming, we will test it with TCP and UDP both. And then we will move on the HTTP. Actually, there's some IoT protocol based on the TCP and some IoT protocol based on the UDP, runs on the TCP or the UDP. So like HTTP work on the TCP. So like first we will understand the what is the architecture of HTTP IoT protocol. It's the request and response basis. So how it is work? Then by the Python programming, we will work on it with Raspberry Pi, and we will use get, post, different method for design the for send the data, or for the client, and the for create the server. We will use the Flux library of the Python, and we will design the server or the web page and send the message or request or response. We will work on it. Then after we'll work on the MQTT IoT protocol. It's also one of the famous IoT protocols, message queue telemetry transport. So what is MQTT protocol? What are the mechanism behind it? Which type of the service is attached? What is the broker? What is the publisher? What is the subscriber? All things we will do. And then Python Paho MQTT, this is the library. By use of this library, we will implement practicals with Raspberry Pi, and we will do the home automation project, something like with it. And then we will move on the COP IoT protocol. It's one of the famous and important protocols. Like its architecture is same like HTTP, but it's the something advanced version of it. It's specially designed for the constant device. Means constant device means which device works on the low power or the battery. For their long life, we will work on the COP IoT protocols. So it's also one of the famous IoT protocols. So we will do with practicals by using Python Python library. Then we will move on to some cloud platform. There's a number of IoT cloud platform like UB ThinkSpeak, Adafruit, IBM Bluemix, and Microsoft Azure. So we will work on it, like on the UB a cloud platform, and how to like operate, how to control the GPIO pins of the Raspberry Pi from the anywhere, or how to analyze our data on the cloud from anywhere, and how to create a rule, like if you want there is some how to send the message on the particular when the publisher publish their message or the data, you want to get a notification or you want to notify by the Twitter or the SMS. So that thing we will do here. Then after we'll move on the some analytic part, like by using the big data and the cloud computing and the big data. And the cloud computing will start the very brief, like from this introduction of the cloud computing. Then we will work on the different services of the AWS, Amazon's web service, and how we can like interface the different service with the AWS IoT service. We will work on it. And the big data will start from the very beginning of the big data, and what is the role of big data in the IoT sector, how we can use it. This thing we will cover here. Then we'll work on the AWS IoT, Amazon's web service IoT service. We will start and we will work on it. And these things all we will do by the practical. And here we will connect our hardware, means Raspberry Pi, with AWS IoT platform, and we will send, publish, or subscribe by using this platform by using the Python programming. Then we will interface the different services like SNS service, DynamoDB service with AWS IoT by creating a role, and we will store our data on the cloud or the AWS. And then we will if like we want to notify when the publisher will publish some data. So this thing we will do by using the SNS service, also simple notification service, by creating a rule of SNS. Then we will interface it with the AWS IoT platform. So this thing we will do. And then after we will do one IoT projects on plot the location and route of the Google map. This is smart dustbin management. And in area there are the different dustbins, and all the dustbins will be attached. Is the IoT enabled dustbin, means all the dustbin is not a normal dustbin, it's the smart dustbin which is connected with each other and the service provider. And when any one of that dustbins will be full, it will be automatic notify I am full, something like. And the service provider also get a sorted route for go on particular destination. So these things we will do by using the GPS module and Raspberry Pi and GSM. So this is the practical projects we will cover, and the home automation projects also we will do. So now let us start from the beginning. Internet of Things. So first thing, what is the Internet of Things? So we can define it like it is a network of all the physical device. A physical device may be anything like fridge, TV, AC, cooler, sprinkler, motor, anything, page, shirt, hair, any normal device, any normal things. So network of all the physical device in this such way they can communicate with each other or share the data over the network. So we can say this is the IoT. Actually IoT, now every big company using IoT for for increase the productivity. Actually the IoT convert a normal device into the smart. So now that's why the every company are using IoT for convert their device normal into the smart. So like every big company define the IoT in their own terms. Some of the company define the IoT in the IoE, Internet of Everything, IIoT, Industrial Internet of Thing. Just take a look. Cisco. Cisco defined the IoT in the term of Internet of Everything. According to Cisco, it's the type of technology which allows to connect all the physical devices or the device things, uh, data, all the physical device things, data, or the people connect with in one particular network and share the data over the network, and it will, the resultant of it give a uh, valuable output and increase the productivity of the industry. So this thing. And Arison defined the IoT in the term of network of society. According to Arison, is the network of all the physical device where they will connect it and communicate with each other like a human. GE defined the IoT in the term of IIoT, Industrial Internet of Things. According to GE, is the technology which allows to connect all billion device like a machinery of industry or the robots of industrial robot to connect with each other and give the productivity results. IBM defined the IoT in the term of sensor for everything. According to the IBM, is like technology which allows to all device to use the sensor for everything in the world. We can say Microsoft. Microsoft defined the IoT in the term of the next generation. Start with your thing. According to Microsoft, it doesn't matter what is your thing, you can apply IoT with anywhere with any type of the device. Boss. Boss defined the IoT in the term of the next generation of Internet of Things. According to Boss, it's a network of all the physical device, and it where they all the devices will be share the data over the network, and it will be gathered that much data. In the future, it will work as the internet for the next generation. So here is the some introduction. Uh, the some company define the IoT in their own terms. Some of that is Internet of Everything. Some of that is IIoT, Industrial Internet of Things. Some sensor for everything. The next generation of the internet. So now one of the big question is how it is the possible to convert a normal device into the IoT enabled device or into a smart device. Like this thing we can do by use of some hardware, some IoT hardware, some microcontroller, some software, some programming language, some wireless technology, some IoT protocol, some sensor, some actuators. And by embedded all that things, we can make or convert a normal device into the IoT smart device or IoT enabled device. So just take a look. Let's start with some common hardware. So like hardware platform is an integral part of any IoT application which is used for create or build die projects or the prototype. So there are the number of hardware platform available in the market. Now I'm going to cover the top hardware platform which is used in the current market. The first is the Raspberry Pi. Raspberry Pi is look like a credit card size of computer. It's have all the facility which comes normal computer. Here you can see it's have 4 USB port, one Ethernet port, this one Ethernet port, and audio ports, and we can also interface external LCD or the camera because here this one is LCD port. We can interface external LCD and also external camera like Pi camera, this thing here. And this one is HDMI port. Like if you want to interface with your laptop or with your desktop, so we can use by using the HDMI port. And this one is the power port. And this is based on ARM processor. It's based on the Linux operating system base, and this is have a ARM processor, and it's the Wi-Fi and the Bluetooth enable. We can like interface with the, or we can use the Wi-Fi on also or the Bluetooth also, or in the form of the hard disk. Here we can use external memory card of 62 GB or 16 or 632 GB and more than that. And here you can see it's have the some couple of the pin. This pins, it's the 40 pins, and in this 40 pins there is 26 GPIO pins, means general purpose input output. That means we can use as a to input or output or the for control the any device. There are 26 GPIO pins, and the sum of rest of pins, the sum of that is ground, some of that VCC, some SPI, I2C, or the UART. Like ground means negative, and the VCC means positive port, and I2C, SPI, and UART. These three are the communication bus which is used for send the data from IC to the another IC. So like we can also use is have all that three facility also on board. And actually this board is developed by UK and manufactured by the China. Is aimed to develop to spread the computer knowledge between the students. And now in the current market, this is the top hardware which is used for build the IoT projects. And for the programming, we can it's also support the different programming language, but we will work on the Python. And by using this particular programming language, we will program it. We will interface the different sensor with module, this hardware module, and we will use the different apply the different IoT protocols with this particular board. Like we will work on HTTP, COAP, or MQTT IoT protocols. This is the application layer protocols, and by using this, we will control the things. We will analyze the data, and we will build a different IoT projects also. Now let's move on the other boards. Like here you can see here the all the IoT structure, and this is here you can see there is something less number of the pin. This is the Raspberry Pi Model 2, and this one is Raspberry Pi Model 3. It's have the Bluetooth and Wi-Fi facility and the 4 USB port, and there is only the 2 USB ports, and it do not have the Wi-Fi and the Bluetooth facility. There are different version of it, but we will work on the Raspberry Pi Model 3. Now next, Arduino Uno. Arduino Uno is the manufacturer is developed by the Italy, and it's also one of the famous board which is used in the current market. And like here, one of the best feature of this board is the open source platform. Open source platform means we can interface the different type of the hardware, or also we can program it, we can with the different type of the software also. It support the all the hardware and the software. Here you can see this 6 pins, yani there's 6. This one A0, A1, A2, A3, A4, A5. These 6 pins are analog input pins. Means these pins we can use as an analog input. What do you mean the input? Means we can receive the something from the other hardware or the other module. Like in our computer, the keyboard and the mouse work as the input, and the printer or the monitor work as the output ports. So here, so in same way, this one is analog input. We can interface the some hardware or the some module which give their value in the analog form, and that value will work as the input for this module. This is the analog input pins. And here these are all the 6. And here from 0 to 13, 0 to 13, this 14 digital input and output pins. Means it's have 6 analog input pins and 14 digital input output pins. Means this means we can use as a input or output, digital input or output. And here you can see the first thing is input and output. Means we can interface the some module which give their value in the input form, or output means we can give the output in the digital form. Digital form means 0, either 0 or in 1, any the two fixed value. And here you can see here the sum of that pins are some wave type of sign. Like here on the 3, 5, 6, 9, 10, 11, they have some wave type of sign. These pins are digital and input and an output pins, but these pins also work as a PWM pins, means pulse with modulation. We can get the by using of that pins, and by programming we can receive analog output on this pin. This only in these pins like 3, 5, 6, 9, 10, 11. These pins work as the PWM pins. So like it's have 6 analog pins, 14 digital input output pins, and 6 analog input pins. This analog input, not output. And it's also have a 6 PWM pin. It support I2C, SPI, and UART communication bus. And here is CLTX and RX facility also. And it's based on 8 mega 328 microcontroller. What's the microcontroller? It's the like computer on a single chip. Another way you can say it's have all the specification or all the facility which comes normal computer. So here is the like memory is very less, like near about 24K and KB, and is do not have a facility of Bluetooth and the Wi-Fi. And you can see this 6 pins. These 6 pins are connected with a microcontroller. Like here is some analog and some digital and some PWM pins. So we can interface any type of the hardware with this module. Like if I talk about the software for this particular board, the company developed one particular IDE that is known as the Arduino IDE, and it's by using that IDE we can program it and we can interface. Sorry, we can insert or upload the program inside of the microcontroller. But there are some guys who do not want to work on the or who do not want to learn any other IDE who is perfect in any other programming languages like embedded C or the JavaScript or anything else. So like they can use that programming language and program it this particular board and upload their program inside of microcontroller by using these pins. Like from the Arduino IDE, uh, we can use the USB cable for the upload the program. Here is the one port of the USB and other port will be of USB. Other side of the USB will attach with the laptop, and we can upload directly program from our laptop the inside of the microcontroller. If you are using Arduino IDE, like if you're using any other platform or any other programming language, then first you have to program it, then you have to convert it into the hex file, and then by using the external programmer, this is the external programmer module, you can interface with this. You have to interface with these pins, and then you can directly upload the program inside of the microcontroller. And this is the power port and some LED and some features of it. But this is also mostly used in the IoT prototype and the projects, build the projects, but it do not have a Bluetooth and the Wi-Fi facility, so that we can interface external Bluetooth module or the Wi-Fi module with this particular hardware. ESP826601 as a Wi-Fi module, or SC05 or SC06 as a Bluetooth module. We can interface it by serial TX and RX, and we can make it Wi-Fi or Bluetooth enabled platform, and then we can use it for the IoT, build the IoT projects. And this is the all the internal architecture of this. This is the reset button and the digital pins, analog pins, power pins. So these are all the features. This is the microcontroller, 8 mega 328 microcontroller, and these 6 pins also known as the ICSP pin. Okay, now let's move on the other board, ESP8266. ESP8266 is also known as the Wi-Fi module, and we can also program or we can also use this module as a IoT hardware module platform. Like here, all the 8 pins are. So there is 8 pins RX, and there's all the architecture. It's have the 2 GPIO pins, means general purpose input and output pins. That means we can use as a control the any device. TX and RX, VCC, ground, reset, and CSPD chip on power and reset it. Like this module, we also like use it with Arduino UNO for make it Wi-Fi enables, or we can directly use this module as a microcontroller and we can upload the program of inside of this microcontroller, but it's have very less memory. So it's depend on the user application which type of the hardware should choose. Like here is only 2 GPIO pins and CLTX and RX and VCC and the ground. It's work on the 3.3 voltage. Do not attach directly insert with the 5 volt, attach with the link with the 5 volt, it will be damaged. And here antenna. This is the on-chip antenna, and by using, we can program it on the Arduino IDE platform, and for upload the program from software or from the laptop to inside of this module, we have to use USB to TTL converter, and by using that module we can upload the program inside of this microcontroller. This is also widely used because it's a very you can say very cheap, uh, cost is very low, like near about uh, 200 rupees near about it, and so that's in the current market is also widely used this module for build the IoT projects, but it's work very slowly because it's the processor and the like controller, sorry, like memory is very less. Now there are some other boards also which is used in the current market, or for the build the IoT projects like Intel Addition, Intel Galileo, just boards, Banana Pi. It's also look like same as the Raspberry Pi. It's also have Bluetooth and Wi-Fi, HDMI ports, Ethernet ports, GPIO pins. BeagleBone Black is also used, and Node MCU is just advanced version of ESP8266. That one is ESP826601 module, and this one is ESP826612E module. It's a 12E. It has something advanced version. It's only the advanced version with some more specification of ESP8266 or the previous version. And that 12E module is 12E version module is known as the Node MCU. It's have more GPIO pins, more other specification as compared to the previous version. And Flutter, these are the top boards which is used in the current market for the build IoT projects or the prototype. And like these are the top company who manufacture this type of the boards like Intel, MediaTek, Texas Instrument, and Broadcom. So these are the this company who manufacture the IoT hardware or the microcontroller, especially for the build the IoT projects or prototype. All of you are getting. So now let us start with the IoT actuators. Like actuator also uh, play the big role for the IoT. And in the simple term, we can define the actuator like if in any machine, actuator is responsible for uh, control the things or the give the mechanical rotation. So there are some IoT actuators which we are work on it, like we can see here. Servo motor. Servo motor is widely used in the industry for robotics application, for manufacturing, and or the different way for the motion. It works on PWM, means by send the different pulse from our IoT hardware, we can control it, we can use it. The servo motor. Stepper motor. Stepper motor is like a uh, is the type of the DC motor which give their output in the stepwise. Like DC motor rotates in the 360 degree in the full rotation, but it's give the output in the stepwise. And it's also used in the IoT prototype or the in the industry. And if I talk about the integral part of it's have a one magnet and the some coil of it. And in the like the basic difference between the DC motor and the stepper motor is in the DC motor the magnets are the fixed, and the coil rotates in the different direction in the DC motor according to the magnetic force. But in the stepper motor the coil is the fixed and the magnets are rotate. So this is we will also work on it, this particular motor, and how to control, how to use it, and how to use in the different IoT application. We will work with the practical. DC motor, this is the widely used for in IoT projects or prototype. It's generally convert electrical energy into the mechanical energy. And if I talk about the inside of this inside of this motor, there is a one coil and the magnet, and the coils are the fixed at the sorry, coil is the middle of that, and the magnets are the fixed on the corner. And accordingly, when we'll supply the small current in the coil, it generate electromagnetic fields, and according to that it's move. So we will do with this thing with the practical linear actuator. Linear actuator is also used in the IoT prototype, and like it's used for create a linear motion, and mostly it's used in the printer or the some disk drive printer, this type of the device. Relay module. Relay module is like a magnetic switch. And if I talk about the main part of the relay, the inside of that there is a one coil, and other side, when we will pass the small current in the inside of the coil, it generate a electromagnetic fields, and it's attract or repulse the magnet. And according to that, we can control the much larger electric current from the by the pass of the small current. By passing the small current, we can control the much larger electric current. This is used for control the heavy devices which is work on the 220 volts from the small current. We will use this thing, and we will work with the practical how to use relay module, how to current, how to apply, what happened, we will insert the IoT prototype with any particular AC device, like with fridge or something like. So we have to use the relay for connect the electronics device with the electrical device, which works on the less than 12 voltage and more than 12 voltage. For connect the both things, we have to use relay module. Now let's move on the IoT sensor. That the number of sensor available in the market, and it's depend on the user application which type of sensor they should use. Actually, sensor also play the big role for the IoT. It's worked as the eye and ears for the IoT projects, and we cannot think the any project IoT projects without the sensor. It's not possible. And in the simple way, we can define the IoT sensor. The sensor is a electronics hardware or a module which sense change in its surrounding and give the corresponding output. Which sense change in its surrounding and give the corresponding output. And it's play the big role for the IoT. Now let's talk about the some top sensor which is used in the current market. Like here, the DHT11. DHT11 is temperature and humidity sensor used for measure the temperature or the humidity. Soil sensor is used for measurements of the moisture level of the soil. DHT22 is also temperature and humidity sensor, but it's give the more precise value as according compared to DHT11. LM35 is only is the temperature sensor, is give the only temperature value. BMP 180 is the pressure sensor. ACSR04, this is the ultrasonic sensor which is used for measure the distance. IR sensor. IR sensor is infrared sensor which is used for measure the presence of any objects. If like there is any objects, then it's will give the something different value, or the corresponding value it will give. It's used for measurement of the any object inside of it. So there are the number of sensor like PIR sensor, LDR sensor, photodiode, phototransistor. PIR sensor is used for detect the motion. So that's why it's also known as the motion sensor. LDR sensor, photodiode sensor, and the phototransistor sensor. These all three are the light sensor. Is also used as a light sensor. MQ3, MQ2 is the alcohol sensor or the gas sensor, is also known as GSM module, GPS module, and the pi camera. This is the image sensor. Accelerometer like M6050, sorry, gyroscope M6050 module. This is used for balancing. This is the most of use in the quadcopter, on the in the ship or the aeroplane for the balancing. And for we can use it in the IoT projects also. It's depend on the user application, what is their projects and what they want to do. Accordingly, we can select the any sensor. There are a number of sensor available in the market. Now let's move on the other topic. Like here, if I talk about the IoT architecture. In the IoT architecture, the first step is hardware microcontroller. Select the particular hardware platform or the sensor hardware actuators. All these things comes in the first step. Then in the second step, choose the particular wireless networking technology. There's a number of wireless technology available, so choose the one particular wireless networking technology. Then in the third step, go with any particular one IoT protocol. Like in there the number of IoT protocols, like in the application layer, there is a number of the IoT protocols like HTTP, MQTT, COAP, AMQP, XMPP, so that the number of the protocol available. So accordingly, your projects, you can select the any type of the IoT protocol. And then in the fourth step, what is the IoT? Is the network of the all the physical device. We already first like attach your device with a particular sensor or actuators or the hardware. Then now the second part is create a network, create a wireless network for connect the other things. Like there is a one hardware devices here and some other country. The first I will attach these things with the particular hardware or the sensor or the actuator. Then I will choose any one of that wireless technology for create a network. And then for sharing the data from here to that destination, from source to destination, I will choose one particular IoT application layer protocol. And then by use of that protocol, I will send my data or share my data from source to the destination. So these are all are the IoT architecture. Hardware, select the particular hardware, sensor, or what is called actuators. Then choose the one particular wireless networking technology. Then select the one particular uh, IoT application layer of protocols like MQTT, COAP, XMPP, AMQP, the number of the IoT protocol, and then create a network or send or share the data over the network by using Python programming. So this thing all over we will do with the practical, and how to work on the different wireless networking technology, how to like create a network, wireless network, and then how to then we will move on the TCP and UDP. By using the Python socket programming, we will send the our data from source to destination, and we will find the what is the difference between the TCP and UDP. And then we will work on the IoT application protocols, application layer of protocols. First, we will apply with HTTP, and by using the Python Flash library, we will create a web page or the web server, and our hardware, like our hardware Raspberry Pi, is work as a client, and that work is just as a server. And we will send the data, or we will control the things from the anywhere by using HTTP protocol. And then we will work on the MQTT protocol, like the number of the company, like our ATM machine or what's Facebook Messenger, based on the MQTT protocols is developed by the IBM. Then by using the Python Paho MQTT library, we will work on it. We'll publish our data on the cloud and we will analyze it. And then by the subscribing, we can control the any device from anywhere. Then we will use the cloud platform. Actually, by using the cloud platform, we can analyze and we can control the things, and we can analyze our data from the anywhere in the world by using the cloud platform. There's a number of the cloud platform, but we will work on the UB and we can also work on the different cloud platform like Adafruit, IBM Bluemix, Microsoft Azure. There are the number of the IoT cloud platform available. And then after, like We will by using the Python programming, we will apply the different IoT protocol. After the MQTT, we will work on the COP. COP is the if you will go in the market for the industry for the job purpose, there is a mostly two. You should have a knowledge of the COP and the MQTT, because this IoT protocol is widely used in the current market, COP and MQTT mostly. And then we will work on the big data and cloud computing, different services of the Amazon's web service. We will work with the practicals with the DynamoDB, SNS service, S3 service, the different service, cloud watchings. So we will use that service, and we will like with the IoT, and we will analyze our data. Then we will work on the big data, and we will analyze our data, and also is the basic introductions and what is the correlation between the IoT, how we can use the IoT data with that using the big data technology. Now the number of the in the India, the number of the company, either that is the technical or the non-technical, both type of the company using IoT for increase the productivity or the reduce the time something. And the non-technical company is used for store data management over the clouds, or the store the data over the clouds, and their analytic parts they are also doing. So in the market there are some IoT developer for develop the IoT hardware, IoT analytics, and for the space, and also IoT programmer. These are the some top job profile which is you will get a job in the current market, and this is the requirement. And if I talk first, I will now I'm going to cover the some most important part of the IoT. Then I will move on the wireless networking technology. Like if I talk about the application of the IoT, the application is very big. Here there's a number of company there's some Google, Facebook, Amazon's, IBM, Cisco, TCS, Wipro, Infosys, Accenture, Cognizant. There's a number of the company who using the IoT, and the either that is the technical or the non-technical company. The technical company for in the industry, in the manufacturing area, manufacturer company also using IoT for convert a normal device into the smart, or the for the automation. And the transport sector, that company also using the IoT for tracking part for track their device. And healthcare sector is very big market for the IoT. There are the number of startups in the India, also abroad, that based on the healthcare sector. Like what happened, their company designed some type of the device, or some type of the band, handband, which is analyze all the disease or what is your going on inside of your body, and that is the connected with your personal doctor, or in the or one particular cloud, where their doctor can analyze the what the going on in the patient or their customer body. If there is any problem or any disease, they will inform you, like these things. In the agriculture sector, this is also mostly widely used for analyzing, for control the things, for analyzing the all the data, these things for visualization also. So the in agriculture sector is also very big scope for the IoT. And these are some company who are there we can get a particular job, or they are searching some uh, employee who is working on the IoT, and they have a different knowledge of the different domains of the IoT. The TCS, Wipro, Infosys, Accenture, and the Cognizant. And the non-tech, I already said you in either technical or the non-technical, both type of the company using the IoT for renewal. And in industry to adopt this technology is the fourth revolution for it, for the automation, and all the system will be moved on the automatic. And here you can see the IoT platform. Now every big company have their own platform, like IBM Watson is the IBM platform, IBM developed the MQTT, and is the MQTT like platform protocols is like developed by the IBM in 1999, but that time is not a free. Now it's open source. And now it's widely used in the IoT, build the IoT projects or the prototype. Amazon's web service. Amazon's have a number of the web service like machine learning for analytic, for security, different AWS IoT. So we will work on AWS IoT of the Amazon's web service, and we will do with practicals. We'll do by using the Python, and we will also interface the different services of Amazon's with the AWS IoT platform. Like Google have also have their on the IoT platform. Oracle's, Intel, Azure is the Microsoft, TCS, Azure, Infosys, Wipro, Accenture, Cognizance. All the companies have their own IoT platform, and they are using this platform for increase the productivity or growth of the company. And now this is the right if I talk about the future of the IoT, the future of IoT is the very big, because now it's just start in starting level, especially in India. Now India it's have within the like in the last 5 years, it's more than 200 startups based on the IoT in India, which some of that company provide the service, some of that in the product features, some of that the service type. So the number of the startup is also in India, and this is the good time to move on the this area. And now every person have 2 or 3 devices which is connected to the internet. Like I have my mobile or laptop something, so these are connected with the internet. It's assumed that the till 20 to 2020, 40 to 80 billion devices will be connected to internet. Every persons have at least the 10 devices which will be connected to internet. So you can think about that is the future is very big, and day by day use the people's using this platform, this technology for reduce the human efforts or increase the productivity also. And like here if I talk about the revenue, and if I talk about, so here you can see that in the 2014 to, I have the data of the 2014 to 2020, you can say every day by day, every year is use, and people using this technology, and its revenue is also increasing. So means people like it, and it's help the peoples to increase the productivity or the reduce the human efforts, and by convert this normal device into the smart. And its revenue you can see here is in the different domain, in the city, the smart city, smart building, healthcare sector, transportation sector, home sector. Every year it's revenue is going to increase. And especially in the home automation sector, you can see the revenue is 397 dollar $1 billion. So every year it's increasing. And the topmost uses and application is home automation, then transport. And but nowadays is the healthcare sector is the rate of the growth of the healthcare sector in the IoT is very high as a compared to the other. So now it's a very big opportunity, and Indian IoT market to touch $15 billion by the 2020 according to NASCOM. So it's the right time to move on this technology. So we already know how is it possible to convert a normal device into the smart device or in the IoT enabled device by using some hardware, software, actuators, wireless networking technology, and IoT protocols. So now let's move on the IoT wireless networking technology.
How do we manage the lab sessions? Do we need to install any softwares, or how can we do the practice?
Yes. Today, only the theory parts I will cover, and for the practicals, I will tell you we need some software and some hardware, some kit also, like Arduino, some sensor, Raspberry Pi. Like if you guys, you will manage the kits by your own, so you will enjoy these things because we'll do the 70% practical each
That's
and
what.
everything.
If we don't have those hardware devices or the kit, then it's difficult to do the practice, I think, right?
Yeah, right. Actually, what now? uh, I will tell you, but you will not enjoy these particular things because it's difficult to learn without the practical. And there is a 70% practicals, and I will show you how to do it, and I will also do with you. But if you will do by self, then you will enjoy it. So without the hardware is something hard to go with this thing. You
Okay.
need to buy it. I will forward you list, and which hardware, which sensor we need for this particular training module, and you can buy from. I also there's a may I know your name?
Anil.
Anil. Okay.
Yeah.
Where are you from?
I'm currently from Finland.
Okay, okay, fine.
So, do we get those hardware devices everywhere? Or
Yeah,
what?
yeah, yeah, yeah. You can
Okay.
also purchase online, and everywhere you will get it.
Okay.
Okay. Now, any doubts? Yeah.
No. And do you share any documents on this during this course?
Yes, yes, yes. I will give all the documents, will the study materials. Don't worry, and it will help you in the futures to revise and everything. You will get each and everything which is in the course module.
Okay.
Okay. Now let's talk about the some wireless networking technology for IoT. Actually, wireless networking technology for create a network between the one device to the another device. Uh, Create a wireless network between the one device to the another device so that they can share their data. So there are the number of wireless technology available. Let's take a look. First, Zigbee is Zigbee is one hardware, and by using that we can create a wireless network between the one device to the another device. And Zigbee module is standardized based on the IEEE 802.15.4, and its frequency is 2.4 gigahertz and range is 10 to 100 meter, and its speed is 250 kb per seconds. And Zigbee module is especially used in the industry or the for home automation. For medium level of industry, like if you want to create or personal network, wireless network, then we can use Zigbee. And the most of industry prefer to medium level of industry prefer Zigbee for create a wireless network. And we can also use in the home automation sector because its range is 10 to 100, and accordingly we can select module. Actually, choose the one particular wireless networking technology is depend on the your application. What is the range? Like if I talk about the smart city, for the smart city we can't go with the Zigbee because its range is 10 to 100, and for the smart city we need at least 40 to 50 kilometers and more than that their range. So it's depend on the user application. From home automation, we can go with the Zigbee, or the medium level of industry, we can go with the Zigbee. Now let's move on the Wi-Fi. Wi-Fi is also standard on the 802.11 and its range is approximately 50 meters, and its also speed is 600 mbps, and maximum speed is. And this wireless networking technology is mostly used in the home automation sector or medium level IT industry. IT industry, they're also using the Wi-Fi for the IoT. Create a wireless network. Bluetooth. In the past, we use the Bluetooth for create a wireless networking. Create a wireless network. It's used for wearable device. Its range is very like 50 to 150 meter, and its speed is data rate is 1 mbps, a maximum 1 mbps. And we can use this thing by using the in the home automation sector or in the wearable device also. Jadway. Jadway is also specially designed protocol for the home automation. Like this protocols, this technology used in the and hotels and in the home automation for create a network of different small devices. HVAC, swimming pools, and the different cinema, and also different things. And its range is 30 meter, and frequency is 865.2 megahertz. NFC. NFC means near field communication. It's specially designed for wearable, only for wearable devices. You can see here, its range is only the 10 centimeter, and its frequency is 30.56 megahertz. Data rates is 100 to 420 kbps. Means it's used for the some wearable device which range is very very small, and which works on a small data rates. Then we can go with the NFC. Cellular. Cellular means whatever we are using, the 2G, 3G, 4G network, it's come under the cellular, and it's mostly is used in the smart city or the in the wild area. For that we can go with the cellular wireless networking technology, and its range is 35 kilometer maximums. And for GSM, for the different light, for the 2G, 3G, and 4G, there's a different range, and we can go with the different speed also. So and its setup is something too much expensive. And for that, there is another wireless networking technology, the Sigfox. Sigfox is also used for the wild area, for create a network in between the wild area like a smart city. And actually the cellular cost set up the cellular, all the uh, is very costly. Then we can go with the Sigfox. This wireless networking technology is the less expensive as compared to cellular, and its range is also good, and with the data rates like 10 to 100 PS, and the 30 to 50 kilometers. LoRaWAN is also like one of the wireless technology which is mostly used in the wild area network, for create a network between the machine to machine, or the like in the smart city, in the industrial application. Then we can go with the LoRaWAN also. So we already like a Bluetooth, Zigbee, NFC, cellular, and cellular 2G, 3G, 4G, LoRaWAN, uh, different wireless networking technology. Like it's depend on the user application. If their area is small, from home automation, or the from like industrial, and for wild area network like a smart city, they can select the particular wireless networking technology, and they can go with it. Like it's also depends it's also depend on the hardware. Like some of that hardware which work on the small speed, small data rate, so that we have to choose accordingly that particular wireless networking technology. Like for the variable device, we can go with the NFC also. So it's all things depend on the user application, and then we can select it. Now let's move on. This is a very important part, OSI model. Like what happened, by using the particular wireless networking technology, we create a network between the two devices. And now for send the data from source to destination, or from the one device to the another device, we can select, we have to go with the OSI model. Actually what happened in the past, for every every computer manufacturing company using their own model for share the data between the same uh, type of the computer. But it will be difficult for the any retailer or any user, if they have different type companies computer, for create a network between that computer, or share the data between that computer. For that, the one organization create a one model, that is known as the OSI model, is open system interconnection. And if the company manufacturing company using the same this model, so it will be easy to create a network or share the data between the different type of the computer. So like here what happened, I have here in the source I'm using Arduino Uno board, and in the destination, if that person using Raspberry Pi, different IoT hardware. This what is this thing? This is also a computer. Arduino also computer. Raspberry Pi is also a computer. So both are the different computer. And for the send the data from here to there, like if you use OSI model, then easily we can send the data. We can transmit the data from source to destination or destination from there to here, both way. And in the OSI model, it's there's a some layer is the consist of the some layer, some protocol, and if you follow this protocol, follow this layer, then you can easily send or receive the data. In this layer, there are 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link, and physical. By using this particular layer, we will work on it with practicals when we will use the http mqtt or the something else COAP protocols. Then we will do in this way, we'll program in this way. So in the application layer, there are different IoT protocols like mqtt, http, COAP, amqp, xmpp. All these IoT protocols come in the application layer protocol. Is responsible for send the data, create a network or send the data from source to the destination. Then move on the transport layer. Transport layer is in the transport layer is responsible, is the main responsible for like transmit your data from one place to another place. In the transport layer, there are 2 types of the protocols like TCP and UDP, and some application layer of IoT protocol work on the TCP. Some of that runs on the UDP, like HTTP and MQTT run on the TCP. They follow the TCP, and the COAP IoT protocol works on the UDP transport layer protocol. Then we will work network. In the network IPv4, IPv6, then we will work on it, don't worry. So like here, and each model is responsible for the different type of the work. Like is every layer is specific work, and we will do this thing with practicals. Like we will see the how this layer is working, how this layer is working, then we will do apply the practicals. So I will uh, continue, I will go with this particular topic with when we will do the practicals. Now let's move on the transport layer. In the transport layer, there are 2 protocols. Most is TCP and UDP. TCP means transmission control protocol, and user datagram protocol. And transport layer is responsible for send the data from destination to receive, from source to destination. Sorry. And like TCP, some of the IoT protocols, application layer protocol runs on the TCP. Actually, TCP gives you the guarantee I will uh, uh, send your data in exact destination. Is the connection oriented protocols. It's give you the guarantee I will send your data on exactly address. And if I talk about the speed of TCP is something less than the UDP, and but it's consume too much memory also, and is the very reliable. It's take the guarantee because it takes the guarantee I will send your data on exactly destination. It's reliable. Is the connection oriented? Is the speed is something less than the UDP, and this consume something more memory as a compared to UDP, but is the connection oriented. And for messaging, from send the data or send the message or the something like we use the TCP, and UDP user datagram protocol is the connection list IoT protocol. It just throw your data. It's do not take you guarantee I will uh, uh, send your data on exactly address. Some actually it's fire and forget type. Just fire it, send it, and forget it. It's maybe there is or may not be. It's do not give you the guarantee. But some of like for send the video call or for voice call, we use UDP, and its speed is as a compared to TCP is high, and it's very consume very less memory. The COAP, which is very important protocols which runs on the UDP. So we will do this thing by the practical by using Python socket programming. We will send the data from by using TCP IOT protocol. Then we will send the data by using the UDP. This thing we will do the with practical, and we will get the difference also. Don't worry. Now let's talk about the IoT application protocol. IoT application protocol. There's a number of the IoT application protocols. Like start with the MQTT. MQTT means Message Queuing Telemetry Transport Protocol, which works on the publish and subscribe basis. Like this IoT protocol is mostly used in industry. It's developed by the IBM in 1999, but that time is wasn't open source. Now it's free. So now everyone using this technology, this IoT protocol, this protocol in the IoT. And now, if I talk about is the working or the architecture of this particular protocols. So, like if suppose that there is a two clients, one client this one client this one, and another client is this. Okay, this client send their data to the another client. So this client is known as the publisher, which clients want to send their data to the other clients, that clients known as the publisher. So here this one is the publisher, this one is the publisher. Okay, and this client want to receive the data. Okay, so this client known as a subscriber, and here both clients are not connected directly. There is a one broker, middle of that is broker, and some couple of the company provide the service as a MQTT broker. Like publisher have to send their data to the subscriber. The first publisher have to publish their data on the broker with particular nickname or the topic name. Like here is name is publish 21 degrees Celsius. With one this publisher publish their data on the broker with particular nickname. Okay, if the subscriber know that nickname, then subscriber have to subscribe on the same broker with that particular nickname or the topic name. Then the subscriber will recheck there is any data available with this particular nickname or the topic name. Then the broker will resend to that particular subscriber or that client. Like I'm just repeat you, like there is some client, one client want to send their data, that client known as the publisher, and which clients want to receive that data, that clients known as the subscriber. And the both clients are connected with do not connected directly connected with each other. There is a middle one broker MQ, that is known as the MQTT broker. And if the publisher want to send their data, then publisher have to first publish their data on the broker with particular topic name or a nickname, you can say. Now subscriber want to receive that data, then subscriber have to subscribe on the same broker with that particular nickname. Then the broker will recheck there is any data available with that particular nickname, then the broker will resend it the subscriber. So this is the architecture of the MQTT, and our Facebook Messenger or the WhatsApp or our ATM machine based on this particular works on MQTT. And there are the number of company who provide the service as the MQTT broker. Some local server broker as a Mosquito Mosca. This is a local server broker which runs on the local server. And there are some cloud-based like IBM Bluemix, Adafruit, Amazon's Web Service, AWS IoT, UB. ThinkSpeak. These are the some cloud-based broker. What the difference between the cloud-based broker and the local server? In the local server, in the local server broker, we can send, publish, or subscribe inside of the server. But if you use cloud-based broker, from anywhere we can use it. We can publish and subscribe. So these are, and here you can see the publish and subscribe architecture is runs on the TCP It support QAS, quality of service. I will tell you what is the quality of service. It's also SSL and TLS security. And quality of service means they have a three quality of service: QoS 0, QoS 1, and QoS 1. If you select the QoS 0, your data is actually, it's like a, you can say it's agreement between the send source and destination, or send the data. Actually, if you select the QoS quality of service equals to 0, then your message will publish maximum one time. If you select the quality of service 1, so minimum one time your message will be published. If you select the quality of service 2, then exactly once time your message will be published. So it's just like an agreement between the source and destination, how much time you want message, this type. Now let's move on the other IoT protocol, HTTP, Hypertext Transfer Protocol. This is the request and response basis, and it's work on the TCP also. It's no QoS supports, and it's also SSL and TLX supports, and it's something like as a compared to MQTT, as it's used the get and post post method for client side. If I talk about the architecture of it, so in the simple architecture, there's a one client and the one server, and we can design the server by we will design it the web page or the web server by using Python Flask library, and the client, our Raspberry Pi or the Arduino board works as a client. And the first we will send a request to the server. I want this thing. Then in the response, you will get output in the response form. So HTTP architectures, this thing. COPE is spacely designed. This is known as the Constant Application Protocol. Its architecture is same as the HTTP protocol. It also work on the request and response basis, but is spacely designed for the constant design. Like what happened, the sum of, if you use the HTTP, the speed of the HTTP as is very something less as a compared to the other, is runs on the UDP as a compared to UDP, and this COPE protocol runs on the UDP. And HTTP protocols consume too much power, is takes too much power, and also consume too much memory. So there are some devices which work on the low power or the battery, like our car key, and the some of that device which work on the low power for, or works on the battery for their long life, because if you use the HTTP, so it's consume too much power. So for their long life, we can use the COP, this IoT protocols, and it's run on the UDP. It's user datagram protocols. Like here in this, there is a two layer: request and response layer and the message layer. Request and response layer, there is a four type of layer, like non acknowledgement, non acknowledgement, reset. Like what happened, uh, it's run on the UDP, so it's just fire and forget. You are not sure about that your data will be received, reach on the particular destination. So there are different type of the message layer: acknowledgement and non acknowledgement. Like when your data will be received, or like an exactly address, then you will get acknowledgement. If your data if your data do not reach on the particular destination, so it's automatically transferred to the reset layer, which under the transport layer, sorry, message layer. And the reset layer is transmit the data on the request and response layer, then it will be retransmitted. So here is like we can design one particular server, and this thing we will do. Our the Raspberry Pi work as the client, and we will design the server and send or receive the data or control the things for communication between the device to the device to the server or server to the device, we can use this our protocols, and this is very famous protocols and very useful protocols, COP IoT protocols. XMPP, XMPP Extensive Message and Presence Protocol. This is IoT protocols is also widely used. Is also based on the TLS. Is no QoS supports. It's also the publish and subscribe and request and response basic architecture. This IoT protocols is used for the send the data in the presence in the in the short time, and for the video or voice calling, we are using the XMPP IoT protocol. So these are the some top protocols, which, and we will do the practicals with the HTTP COAP and MQTT protocol with the different library. For the HTTP, we will work on the Plus, and for MQTT, we will work on the PAHO MQTT Python library. For COAP, we will use COPthon. There's a number of IoT protocols, library for the COAP, but we will work on the COPthon. TXthing, we can also do this library. Now let's move on the network layer protocols. In the network layer protocols, it's give the one particular IP to the device, unique IP. If there are two type of version, IPv4 and IPv6. And now we are using IPv4. IPv4 just give the different IP. Actually, IP network layer protocols give the different unique IP to the different devices. Like if you are using the IPv4 is the specific, it's give only the 4 billion address. Now there are the too many devices will connected to the internet. So it's a limited to use the IPv4 because it's only give the 4 billion different IP. For resolve this problem, we can use IPv6. IPv6 give the number of different IP is so solution is IPv6 and we can use IPv6. But now we are using the IPv4 versions. If I talk about the top programming language, so there are the number of the programming languages we can use for the IoT, like Python. But Python is also widely used. Like why the Python? Because we can use the Python in anywhere, like for the web designing, for Android app development, for embedded programming, for machine learning, for artificial intelligence, for natural language process, for analytic parts, for analyze the data, like by using the NumPy and the different data. We can use the Python library. Is the multitask library also, you can say. So the Python is one of the famous and the top most programming language for the IoT. MicroPython is a space, something like the Python, but it's used for the some microchip, some small board. JavaScript is also used for program the for IoT. C, embedded C, one of the famous programming languages, and now everyone start to learn programming language from the C. So C also use, we can also use the C. Java, for the any developer, Java is the first choice. So we can also use the Java for its Lua programming languages. So these are the some top programming languages, and we can use it and we can program, get how the different architecture and the sensor actuators and all the different things. So this is thing all the IoT, and I hope you will get an idea about the IoT with the different what is exactly IoT and what is how we can convert the normal device into the smart or into the IoT by use of different actuators, sensor, wireless networking technology, and IoT protocols. So these are the top, and we can use it. Actually, it's depend on the user application what they want to do. According to that, we can select one particular hardware, the number of hardware platform. We can select one particular hardware. We can select accordingly. We can select the sensor, actuator, wireless networking technology. What is the distance between the different two devices? So accordingly, we can select the wireless networking technology. Then on the specification of or on the quality of the device, we can select one particular IoT application layer protocols. And then by using the Python, there's a number of the Python programming. It's depend on the you and user, like they want to go like Pythons and micro Pythons, JavaScripts, Node.js, and they can by using the one particular Python library, Python programming, can program it and create a network and send the data from one device to the another device. Then after by using the big data and analytic part, something about Pythons, or so we can also like analyze by do analytic part by using the Python, by using the Python and the cloud different things we can analyze our data. And then by using the AWS services, we will also work on the AWS service. So how to interface the different service with AWS IoT, this thing we will work. So I hope you will get an idea about all the course content. Are you getting my voice?
Yeah, and what kind of softwares we require
Okay,
during?
okay. For the software, for the Arduino, we'll work on Arduino ID platform. This is the free. We can download from the Google also. And for the Raspberry Pi, we need a Python. If you are new for the Python, new user for the Python, then I will start from the very beginning. The Python, like here,
Okay.
Python networking, like yeah, yes.
And what kind of software we require for
But
practicing Python?
this two things like
Python. Okay.
Python and the Arduino ID.
Okay.
And hardware will use Arduino and Raspberry Pi and some sensor also.
Okay. And suppose if we don't have the facility to have the hardware devices for practicing,
Like
can we learn this IoT or?
in the true way, I want to say you like I will do the practicals. You can see, and I will give the content also, where you will get each and everything with the image and with programming and with each and everything in a simple way. Okay, so like you will get an idea what is IoT and how to do. Like, but if you want to actually learn in the good way, then please go with the practicals. If you without hardware, I do not take a guarantee. You can like from yourself, you can like learn from the 50% or the 40%. But if you will do the with the practicals with the hardware, so I can give the guarantee you will learn and we will like get the all our knowledge of it,
Okay.
because you will apply with the practicals by yourself. So that's why it will be good if you have the kit.
No, yeah. Suppose if I don't know because here I'll get the kit or not. If I don't get the kit, can I do the practice in this Python and?
In the Python you can do like some of the you can do, some of that you can't do,
Okay.
because and by using the Amazons we will also like get all the kit. And
Okay.
I can give also the some company name of the company who provide facility to transport or sell the kits, where you can get the all the kit also on online or offline also.
Okay.
Any other like any question, any type of the questions if you like ask me the course content. So what is first thing I want to know about yourself, what you're doing and what is your acceptation from the IoT. Yeah, hello, Mr. Anil.
Yeah. I
Yeah.
did not get your question.
Okay, I want to know that what is your field and what is your acceptation from this training.
No, actually, I'm working as a software engineer, but
Okay.
yeah. So I'm just looking to move to IoT.
Okay. Okay. Okay, now if you like, if you go with this particular course content, you will get each and everything idea about basic to the high level with the practical also, and with the different domain,
Okay.
hardware and the programming, this thing also.
So, when we talk about the job perspective, do we have this hardware jobs and the software side, or how this?
Like I
Uh,
didn't like.
when we talk about the job perspective,
Mhm.
so if I want a job in IoT, do I need to work both on the hardware side and the software side, or can I
Like
select only software side also?
you can select only the software side also, like there's a different domain in the IoT. There's a number of the domain like as a IoT programmer, so this thing
Okay.
only the software, but you have to knowledge about the hardware also.
Okay.
you have to knowledge about the like what hardware and how it is working. So
Okay.
IoT programmer, IoT analytics, for
Okay.
like you can go with the big data and different domain for analyze the data. So
Okay.
IoT data, so IoT analytic or IoT developer, hardware developer to develop the hardware platform. IoT cloud developer, develop the cloud platform, IoT cloud platform, like things make UB dot. This thing, there's a number of different domain. In the security also, you can go with. So the
Okay.
number of domains. You can go with the like software also or hardware also, but you have to knowledge about the how to do what is the hardware and how it's working.
Okay.
Hmm. Like any other question?
And the class duration is 1 hour per day or
Like is the like 1 hour or the 2 hour, like maximum is 2 hour or the 1 hour, I will confirm you. I think it's the
okay.
2 hour.
2 hours in total is 40 hours.
Yeah, it's the 40 hours totally
Okay.
2 hours daily. Any other question? Anything regarding to it? Like if you want to something learn something advanced which is not in the particular course content, then you can also let me know, then I will go with that. So are you getting my this screen?
Yeah.
Okay, okay, fine. Okay, thank you so much. Like if you have the any query about it, like if you have any, if you want to learn something anything advanced, something is not in the particular course content, then you can send you can contact with us, and we will attach with this particular module. Okay, and okay, fine that. If you have any doubt, any related questions regarding it, and after I'll give you the guarantee after the end of this particular course, you will feel that yeah, I have the knowledge about this thing and I can move in this particular era. And with the practicals, the special thing here, we will cover the 70% of the practicals with the programming part, Python programming, the mostly Python programming, with the difference of IoT protocols, STP, MQTT, and the COP. COP is especially, and like if you go in the current market in the job, so some of that like a co ask for the cop, some of that ask for work on MQTT, so it will get easy, you will to find the job. And we'll apply with the different hardware also, like Arduino and Raspberry Pi, which is mostly used in the current market. And if you have any type of the doubts related to it, uh, you can contact with us and to give the solutions and all things. Okay, thank you so much.